Every day, millions of people around the world benefit from a technology that allows doctors to see inside the human body without making a single incision. This revolutionary tool, known as magnetic resonance imaging, owes its existence to one man's moment of inspiration. Paul C. Lauterbur transformed the field of medical diagnostics forever. Born in 1929 in Sydney, Ohio, Lauterbur grew up during a time when the mysteries of the atom were just beginning to unfold. His fascination with science emerged early, and he pursued chemistry at Case Institute of Technology. After serving in the Army, where he worked with nuclear magnetic resonance technology, he developed an expertise that would later prove invaluable. The pivotal moment arrived on a September evening in 1971. Lauterbur was eating a hamburger at a restaurant near Pittsburgh when a radical idea struck him. Scientists had been using nuclear magnetic resonance to study the chemical properties of substances, but the technique could only analyze samples as a whole. Lauterbur envisioned something entirely different. He grabbed a napkin and sketched out a concept that would change medicine. His insight was elegantly simple yet profound. By applying magnetic field gradients, he realized he could determine where signals were coming from within an object. Different locations would resonate at slightly different frequencies, creating a spatial map. This meant that instead of just analyzing chemical composition, the technology could create images of internal structures. Lauterbur rushed back to his laboratory at Stony Brook University and began experimenting. His first successful images were humble, showing cross-sections of 2 tubes of water. The resolution was crude, the images grainy, but the principle was proven. He could create pictures of the inside of objects using magnetic fields and radio waves, with no harmful radiation involved. The scientific community initially met his work with skepticism. When he submitted his findings to the prestigious journal Nature, the paper was rejected. Reviewers dismissed it as having no medical significance. Undeterred, Lauterbur refined his arguments and resubmitted. In March 1973, Nature finally published his groundbreaking paper titled Image Formation by Induced Local Interactions. The journey from concept to clinical reality required years of refinement. Lauterbur collaborated with researchers worldwide, improving image quality and developing practical applications. The technology evolved from imaging simple tubes to capturing detailed pictures of living tissue. By the early 1980s, MRI machines began appearing in hospitals, offering doctors an unprecedented window into the human body. The impact on medicine proved transformative. Unlike X-rays, MRI used no ionizing radiation. Unlike exploratory surgery, it was non-invasive. Doctors could visualize soft tissues with remarkable clarity, detecting tumors, identifying brain abnormalities, examining joint damage, and diagnosing countless conditions that had previously required invasive procedures or remained hidden entirely. Recognition for Lauterbur's achievement came gradually but ultimately reached the highest level. In 2003, he shared the Nobel Prize in Physiology or Medicine with Peter Mansfield, who had further developed the mathematical techniques underlying MRI. The Nobel Committee acknowledged that their work had led to one of the most important diagnostic tools in modern medicine. Lauterbur remained active in research and education throughout his life, teaching at the University of Illinois and continuing to explore new applications of magnetic resonance technology. He emphasized that scientific breakthroughs often come from looking at existing tools in entirely new ways. His hamburger napkin sketch had evolved into machines that save countless lives every day. Paul Lauterbur passed away in 2007, but his legacy lives on in every MRI scan performed worldwide. From a simple idea sketched on a napkin to a technology that has revolutionized medical diagnosis, his contribution stands as a testament to the power of creative thinking in science. The father of MRI gave humanity the ability to see the invisible, transforming how we understand and heal the human body.